Have you ever wondered how a rainbow is formed? Imagine this. You're out for a walk on a warm afternoon, right after a quick rain shower. You look up into the sky, and there it is, a beautiful arc of colors, a rainbow. It's a breathtaking sight, isn't it? But have you ever stopped to ponder the magical process that creates this natural wonder? Well, the magic in the sky, as we often refer to it, is not magic at all. It's science. Rainbows are a result of a fascinating interplay of light refraction, reflection, and dispersion. But don't worry, we're not going to delve into heavy scientific jargon. We're here to make it simple and engaging for you. So let's start with light. You know that beam of sunlight that warms your skin? It plays a pivotal role in the formation of a rainbow. When this sunlight meets a raindrop in the sky, some interesting things happen. The light bends, or refracts, as it enters the raindrop. This is because light travels at different speeds in different mediums. In this case, it slows down when it moves from air to water. Then, as it hits the inside surface of the raindrop, a part of it reflects back, like your face does when you look in a mirror. This reflection causes the light to bend again, or refract, as it exits the raindrop. And here's where it gets even more interesting. As the light exits, it spreads out into a fan of colors. This is known as dispersion. What you then see is this splendid spread of colors in the sky, a rainbow. But remember, each raindrop contributes just a tiny part of the rainbow. It's the collective work of millions of raindrops that gives us the full arc of colors that we see and admire. Isn't that fascinating? The magic in the sky is not magic at all, but a beautiful dance of light and water. Now, are you ready to delve deeper into the science behind these beautiful arcs of color? Imagine a beam of sunlight traveling towards a raindrop. That's our starting point in this fascinating journey of light. Sunlight, despite appearing colorless, is a blend of multiple colors, each with a different wavelength. When this sunlight encounters a raindrop, a marvelous phenomenon occurs. As the sunlight enters the raindrop, it slows down. This change in speed causes the light to bend, a process we call refraction. Think of it like a car taking a turn at high speed. The direction changes, doesn't it? Similarly, when light enters the raindrop, its path changes, and it bends. But here's where it gets interesting. Not all colors in the sunlight bend the same way. Each color's wavelength determines how much it will bend. Red light, with its longer wavelength, bends slightly, while violet light, with a shorter wavelength, bends a bit more. This is why we often see red at the top of a rainbow and violet at the bottom. Now, we have this beautiful array of colors inside the raindrop, but not all of them will end up in the rainbow we see. Some of the light exits the raindrop without further interaction. However, some of the light hits the inside surface of the raindrop and gets reflected back inside. This reflected light then travels to the other side of the raindrop and exits out into the air. As it leaves the raindrop, the light speeds up again, causing it to bend once more. This second refraction spreads the colors out even further, accentuating the dispersion of colors we see in a rainbow. So we've seen how the light from the sun, on its journey through a single raindrop, gets refracted, spread into different colors, reflected inside the droplet, and then refracted once more as it exits. This incredible journey, happening in countless raindrops simultaneously, sets the stage for the magical spectacle we call a rainbow. So, the light has been refracted and dispersed, but how does it get back to our eyes? Well, hold on to that curiosity, because that's a story for our next scene. The next stages in our rainbow's formation are reflection and a second refraction. This is where the magic really happens. Inside the raindrop, the light doesn't simply pass through. Instead, it gets reflected off the inner surface of the droplet. Picture it like a tiny mirror, bouncing the light back towards the direction it came from. This is the reflection stage of our journey, and it's crucial in shaping the rainbow. Now, you might be wondering, what happens next? That's where the second refraction comes in. As the light exits the raindrop, it bends yet again. This is because it's moving from the dense medium of water back into the less dense medium of air. Remember how we said light changes speed when it moves between different mediums? Well, that's exactly what's happening here. But here's the interesting part. This second refraction causes the light to spread out even more than it did when it first entered the raindrop. It's like the light is fanning out, spreading its colors far and wide. And because each color of light bends at a slightly different angle, they all take slightly different paths. This is what makes the colors of the rainbow more distinct. It's why you can see each individual color, all lined up in that familiar spectrum. So, let's take a moment to recap. The light from the sun enters the raindrop and gets refracted, or bent. Then it gets reflected off the inside surface of the raindrop like a mirror. And finally, as it leaves the raindrop, it gets refracted a second time, spreading out and separating the colors even more. This journey of refraction, reflection, and a second refraction is what transforms ordinary sunlight into the beautiful display of colors we know as a rainbow. It's a fascinating process, isn't it? And it all happens in the blink of an eye, right above our heads. Now the light has been refracted, reflected, and refracted again. But how does this create the arc shape we all recognize as a rainbow? Ever wondered why a rainbow always forms an arc? It's a fascinating dance of light and angles. Let's dive into this Technicolor mystery. Picture this. The sun is shining and it's raining at the same time. The sunlight, on its journey through the sky, meets a raindrop. When the sunlight enters the raindrop, it bends or refracts, breaking down into its individual colors. This is because each color travels at a different speed when passing through the water. Now imagine the inside of the raindrop as a mirror. The light hits this mirror and reflects off the inside surface of the raindrop. As the light exits the raindrop, it refracts once more, bending further apart into a spectrum of colors. But why an arc, you might ask? Well, each color of light exits the raindrop at a slightly different angle, creating a spread of colors. The amount of bending or the angle is different for each color because each color has its own unique wavelength. This bending and spreading of colors is what forms the arc shape we know and love as a rainbow. Here's another fascinating fact. The rainbow you see is entirely your own. That's right. Your personal viewing angle from the sun to the raindrop to your eyes determines the colors and the shape of the rainbow. If you move, the rainbow you see changes because the angles change. This means that everyone sees their own personal rainbow. So the next time you spot a rainbow, remember, it's not just a beautiful spectacle, it's a personal gift from nature, created by a complex ballet of sunlight, raindrops, and angles, all working together to paint the sky with colors. So there you have it. From sunlight to raindrop to your eyes, that's the journey of a rainbow.